And hello Year 9, we're going to do the solution now to the geometry problem from today's class. So for those of you who weren't in class today, what we had was a triangle like so. We had a 10-degree angle here, a 70-degree angle here, a 20-degree angle here, and a 60-degree angle here. Straight lines here and here. And we wanted to find x. Okay, let's do the question. First thing that we observe is that our triangle is isosceles, and that's because I've got 80 degrees and 80 degrees, so that means this side here and this side here are the same. And before we go any further, let's just give the points some names. So this can be point A, this one can be point B, and this can be point C. Okay, so we can work out what angle A is pretty easily. We've got 70 and 10, which is 80, 60 and 20, which is 80, so that's 160, which leaves just 20 degrees left over for angle A up here. Okay, so we've got that. The other thing we can work out is what this angle in here is, and let's just give our points a few more names. So this can be point D, and here we can have point E. So I guess what we're looking for is angle DEB. But before we do that, let's just work out what angle BEC is. So BEC. So angle B down here is 70. These two together are 80. So 70 plus 80 is 150. And that just leaves 30 left over for this angle in here. So this is 30 degrees. Okay, so how are we going to solve for our angle x? The first thing I'm going to do is I'm actually going to construct another line, and I'm going to construct a straight line through D that's parallel to BC. And there it is. This can be called point F. So we've got a point F here now. And the next thing I'm going to do is I'm going to join point F to point B. So there we go. Point F joins up to point B. And let's take a closer look at this shape that we've actually made. So this shape that I've made here with BC, oops, let's just undo that. I'll try that again. With BC and DF. Keeps wanting to move up. And DF, good. So here it is, and here it is. This may not be perfectly to scale, but what we've got here is with B, C, D, and F, with my DC and my BF joined. So we notice that this and this is parallel, and we can also see that DB and FC are equal, so DFCB is an isosceles trapezium. If you really want to, you can prove DB and FC are equal with congruent triangles, but it's fairly clear, so we'll just assume that they are. Now, we know that angle DCB is 60 degrees, and we also know that angle FBC is going to be 60 degrees. And you might be saying, how do we know that angle FBC is going to be 60 degrees? Well, let's look at our two triangles. Let's look at B, C, and F. So in BCF, we know we've got this side BC is going to be common in triangle BCF, and it's also going to be in triangle CBD. So BC is common to both these triangles. DB is going to equal to FC, because those are the sides of our isosceles trapezium, and angle DBC is going to equal to angle FCD, because those are both 80 degrees and the base angles of my isosceles triangle. So to help you see it a bit closer, I can shade this one here in green, and there's CBD, and I can shade the other one, BFC, in yellow. So there it is in yellow, and these two triangles are, of course, are congruent. I think, did I accidentally say similar before? For the reason SAS. DB equals to FC. BC is common, and DBC is equal to FCB, because they're both 80 degrees from the original triangle. So we've established that FBC is 60. We also know that because DF and BC are parallel, this equals to 60 degrees. This one equals to 60 degrees. Those are alternate angles. And this one equals to 60 degrees. Why does this equal to 60 degrees? Well, if that's 60 and that's 60, and this shape is a triangle, it must be 60 by the angle sum of a triangle. And while we're at it, let's give this point a name. Call it point G. So if I label this on my triangle here, I know that FCB is FBC is going to be 60, so there it is, 60, just write it right over that 70 there. This is going to be 60. This is going to be 60. And this is going to be 60. But now if we look at triangle DF, and I call this point G, DFG, well, it's a triangle with all the angles 60 degrees, so that makes it an equilateral triangle. So let's just put on a line here, a line here, and a line here. It's an equilateral triangle. Hopefully everyone can see that. Alright, now one more little angle to label here, and that's going to be, let's go to my laser pointer here, and that's going to be angle EBF. Now I know this one's 60, I know this one's 10, so this must also be 10 as well. So let's just chuck on the 10 in here like this, and there's the 10, and hopefully you're writing this down with me as I'm doing it as well. Alright, so let's now clear some space here. So we've established all of these things with our line, and we're going to make another observation now, and that's going to be, we've got an isosceles triangle inside here. So let's see if we can see an isosceles triangle, and let's stick with let's change to green. So let's now take a look at this side here, AC and FB. So BF and FA, these are a part of triangle AFB. But hang on a second, angle A up here is 20 degrees, and angle B, or angle ABF down here, is also 20 degrees. So we now know we've got an isosceles triangle. So we know it's an isosceles triangle with AF is equaling to BF. I hope you can see that isosceles triangle there. AFB. B is isosceles because that's 20 and that's 20, and then we could conclude that this side was equal to this side. Okay, so now that we've seen this, we're going to add just one more line to our triangle, to our construction, and that's going to be another red line straight down here, and I'm going to join point A down to point G, right through the middle of that 60 degrees. Now, before we go on, let's just have a quick look at side AD. I'm hoping that you guys are able to see that this is 80 degrees, and the reason that this is 80 degrees is because this is 80 degrees and DF and BC are of course parallel, so this is 80 and this is 80. And for a similar reason, we also know that this one here, this angle in here, ADF, is also 80 degrees. So now we can see triangle ADF is an isosceles triangle. So since we know it's an isosceles triangle, we can label AD is the same. I'm just going to erase that a tiny bit. We can see that AD is the same as AE, which is also the same as BF. Okay, now for the tricky part. What we can see here is we're going to find two congruent triangles, and the congruent triangles I'm actually going to be interested in are EFB, so there it is, EFB, and FGA. And you might be saying, why are these two triangles congruent? Well, let's draw them up separately. Let's first of all draw EFB. So EFB looks like this, and like this. This one is not a very good EFB. It's not very to scale, and in fact it's so bad I'm going to draw another EFB. It's like this, okay, one more chance, here we go. This is going to be a much bigger angle, like this, and like this. So here is an EFB. There's my E, there's my F, and here's my B. So first thing to look at, let's actually look at what angle EFB is, see if we can work out how big it is. So EFB is 60 degrees for DFB, plus another 80 degrees for angle AFD. So this is a very big angle in here, and we've got this one here as 140 degrees. We can immediately see that we've got 30 degrees up here, but I'm more interested in this one down here, this EBF. This is going to be 10 degrees. So I know that this is going to be 10 degrees. Now my second triangle I'm very interested in is triangle AGF. So let's draw AGF, and AGF we can just fit it up here. So we've got a vertical-ish line for AG, another line up here that can be my point F, and another line out here like this. Okay, so first thing I noticed is that angle AFG is 140 degrees because it's actually the same angle as EFG. EFG and AFG are the same angle. So I realize that this is going to be 140 degrees. Now let's go back up to this angle here. This is 20 degrees, this angle DAF. But if I look at triangle ADG and AFG, well, AD is the same as AF, DG is the same as FG, and AG is just a common line, or a common segment or interval. So this triangle, ADG, is congruent to AFG. So now that we know that they're congruent, we know all the matching angles are equal. So that must mean, since the whole thing was 20, this part, angle GAF, is equal to this part, angle DAG. So there we go. And just to highlight it, we can see that this is equal to this because they're matching angles in our congruent triangles DAG and GAF. So we can now label on, okay, here's my point A, here's my point F, and here is my point G, where we know this is 10 degrees. But we also know something else. We know that AF is the same as FB. I've marked them with those two little lines there. So we know AF and FB are the same thing. AF and FB are the same. So now we know our two triangles are congruent. EFB and AFG are congruent by the AAS test. So we've got these two triangles that are congruent by the AAS test. But if our triangles are congruent, that of course means that all the sides, all the matching sides, have to be the same. So let's go look for some matching sides. Well, I know that EF is the side opposite the 10 degrees, and GF is the side opposite the 10 degrees. So that must mean that EF and GF are the same. GF and EF are the same. But if we go back to our original triangle now, we can see that GF is one of these sides in this little equilateral triangle I had before, GFD. So it's been marked with one line. So I can then mark EF with one line because I know that EF and GF are the same. And I think I can also erase these now. They've served their purpose. So the final triangle we're going to examine is triangle DFE. DFE. And I'm going to draw a bigger one of these. Triangle, here it is. D, F, and E. Not to scale. E, F, E. So let's see if we can work out what this is. The first thing I see is fantastic. EF and DF were the same. We've shown that. So let's label them. We have DF and EF the same, but I also know that this angle here, EFD, is 80 degrees. So let's chuck 80 degrees on here. But as this is an isosceles triangle, these angles must be the same. So if this is 80, they've got 100 degrees to share between them. So that must mean they're 50 each. So this one is 50 degrees. And this one is 50 degrees. So back on our original triangle now, I can see that angle DEF is 50 degrees. DEF is 50 degrees. There it is. DEF is 50 degrees. So we might make a bit of a mess on our triangle now, but here we go. DEF is 50 degrees here, is 50 degrees. And let's have a look for angle X. We can see DEF is 50 degrees, but angle BEF is 30 degrees. We worked that out right at the start. So if this one is 30 degrees and this whole one here is 50 degrees, we can see that X must be, or X degrees, must be the 50 degrees minus the 30 degrees, which is 20 degrees. And we are done. X is 20 degrees.